102, Exponent Rules Part 1. We're going to start with a power review. 3 to the 5th power, what does that mean? What are the parts? What are the vocabulary for that? So if I say 3 to the 5th power, 5 is my exponent, and 3 is my base. 3 to the 5th power means 3 times 3 times 3 times 3 times 3. So notice that I have 5 factors of 3. One of the most common things that trips students up is that they think 5th power means there must be 5 multiplication signs, but really there's 5 factors of 3. So in fact, I have 1, 2, 3. I only have 4 multiplication symbols. So be really careful about that. First, we'll look at product of powers property. We'll start with number 1. And then we're going to kind of work backwards and look at what the actual property is. So first, we're going to kind of just explore and discover that. So this says a squared times a cubed. So a squared means a times a. A cubed means I would have 3 factors of a. So altogether, I need to think about how many factors of a I'm multiplying out. And I have 1, 2, 3, 4, 5 factors of a, so I could write this as a to the 5th. So by simplifying, we're trying to put all those things with the same letter together. For 2, I have 7 cubed. That's going to be 3 factors of 7 times 7 to the 5th, so 5 more factors, times 1 more 7. So now we need to go through and figure out how many 7s am I multiplying up. Well, you had 3 here, plus 5 more is 8, plus 1 more would be 9. I think we're ready now to go ahead and write down our property, and then we'll go back and do problem 3. So I think I made it really clear with example 2 that when we are writing all these out and we're multiplying out all those factors, we're really adding the exponents. So my property I'm going to write as a to the mth power times a to the nth power is going to be a to the m plus n power. So we're really just adding those exponents when we have the same base. Something else to look at here is that when I'm multiplying up all these 7s, it doesn't become 49 to the 9th, right? I'm just counting up how many 7s. The base is still 7. I'm not changing the base. I'm only changing the exponent. For our last one, for number 3, I'm going to go ahead and use my property. So my property says I can add my exponents. So I will write this as negative 6 to the 3 plus 2 power would be 5th power. And then I'm going to take it one step further on this one. I could also write it as just negative 6 to the 5th power. And that's because I know I have an odd number here. My answer is going to be negative. I don't really need to have those parentheses. So there's 2 ways I could express that one. And if this was a test or quiz I was giving, I would give full credit for either answer. Our next property is quotient of powers property. So again, we're going to kind of start this by looking at some examples, and then we'll work backwards and we'll figure out the property. So x to the 10th divided by x to the 5th. I can tell I'm going to have to write these out really small. So x to the 10th, 1, 2, I have to have 10 factors here. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then in my denominator, I have x to the 5th. So I need to write out 5 factors of x. So the way division works is if I have x divided by x, that's just a 1. So when I have the same thing multiplied on the top and bottom, I can cross it out, it makes a 1. I have a couple more factors of x divided by x that are just 1s. So I can cross out all 5 of those, and then I need to think about how many I have left. So I am left with, in the numerator, 1, 2, 3, 4, 5 factors of x. That's going to be x to the 5th power. My denominator is really just a 1 at this point. And I don't need to write down a denominator of 1. So my answer will be x to the 5th power. On problem 2, I am going to go ahead and simplify my numerator first using what we learned in our last activity, our last example, set of examples. And I know if I have x to the third, that means 3 factors of x that are written out. X to the seventh means 7 more factors of x written out. So altogether, I would have 3 plus 7, or 10 factors of x that are written out. So now I have x to the 10th over x to the 6th. So now I need to write all those x's out again. So this should be 10 factors of x. I'm just double checking my counting. I'm dividing by 6 factors. So I can always cross out that lowest number. So I can cross out 6 of them. And every time I cross out an x divided by x, it's just making a 1. X divided by x is equal to 1. 6 divided by 6 is equal to 1. 2 divided by 2 is equal to 1. So anything on the top and bottom of a fraction like that is just going to simplify to 1. And after I take away those 6 factors, and take away should be making you think about subtraction, I'm left with 4 factors of x. That's going to be x to the 4th power. So the way the quotient of powers property works is I can take those exponents and I could subtract them, m minus n. So if I have a to the m power divided by a to the nth power, I have a to the m minus n power. We always have to state something to make sure our denominator is not equal to 0. So here we say that a can't be equal to 0. So now we're going to look at examples 3 and 4. 3 and 4 are definitely trickier. We might want to write these out again just to get a feel for what's going on. Writing them out is always a good way to solve. So now I have 1 divided by x to the 6th times x to the 8th. So it really helps sometimes when I'm multiplying fractions to make them both into fractions so I can kind of tell how that lines up. Because I know I need to multiply numerators together. I know I need to multiply denominators together. So by writing out that x to the 8th divided by 1, it kind of helps me figure that out. So 1 times x to the 8th would just be x to the 8th. X to the 6th times 1 is just x to the 6th. And now I could use that property that we just came up with where we subtract. So 8 minus 6 is 2. So I am going to simplify this as x squared. The last one, if I was to subtract 3 minus 5, it gives me something negative. So this is kind of a strange problem. I want to go ahead and write this one out. So x to the 3rd means I would have 3 factors of x. X to the 5th means I have 5 factors. And just like before, we can cross out our lowest number of factors. So that means I can cross out 3 factors. So what's different on this problem is my factors of x are not left in the numerator. They're left in the denominator. And that makes sense because 5 is bigger than 3. So when I cross out those factors that they have in common, they're going to be left in my denominator. So x squared goes in my denominator. Just like before, every time I cross out an x divided by x factor, I'm left with a 1. So my numerator will just be 1 at this point. So I have 1 divided by x squared. So I could kind of further refine that property. And whenever I want to subtract and figure out what's left, if I start with that bigger number, if I started here and I did x to the 5 minus 3 power, that would have worked. So I need to start with that bigger number, that bigger exponent, and then I need to keep them where that bigger exponent is. So since I had more factors in the denominator, my remaining x's needed to be in the denominator. We're going to look at kind of a special case now. 6 cubed divided by 6 cubed. So first I'm going to write it out. Always a good way to explore a new property. So this would be 6 times 6 times 6 divided by 6 times 6 times 6. I can tell already writing this out that some of you are going to look at that 666 and be concerned. I'm really sorry about that. Did not think when I picked that number. So every time I have a 6 divided by 6, that makes a 1. So I have effectively crossed everything out here. So because 6 divided by 6 is a 1 times another 1 times another 1, my answer for this is just going to be 1. Now let's look how this works in terms of the property. So using the quotient property. The quotient property says I can subtract. So if I was going to subtract, I would make this 6 to the 3 minus 3 power, which is 6 to the 0 power. So from this, is really coming the zero power property, because I know that this has to equal 1. So in this case, we've proved that 6 to the 0 power has to equal 1. By writing it out and by using the property, we know they need to be equal. So our zero power property is that any number except 0 raised to the 0 power equals 1. And we just want to note that 0 to the 0 power is undefined. Using algebraic symbols, we can write the rule as. And so here, remember, a means anything. It's that variable. So anything to the 0 power equals 1. So let's go ahead and practice that anything to a 0 power equals 1. So here, the 2/3 is in parentheses. That whole thing is being raised to 0 power. That means it's going to equal 1. On number 2, same thing. We've got parentheses around the -7, so that whole thing raised to 0 power. So that's going to equal 1. 3, I don't have parentheses. So I have to remember order of operations. I would do parentheses and then exponents and then multiplication and division, and then adding and subtracting. So first I would do this exponent part. 5 to the 0 power will be 1. Then I would do the multiplication part, and I'm essentially multiplying by that negative sign. So because this one did not have that minus sign included in parentheses, it turns out to be a -1. Number 4 is referring back to that property that we just learned, and we know that 0 to the 0 power is undefined. So for example 1, it's asking us to simplify 8.4 to the 0 power. So right now I have anything to the 0 power, that's going to equal 1. These are examples now to kind of help prep us for the quiz that goes along with this lesson. Example 2, simplify 13 to the 8th power divided by 13 squared. So I am going to first write this as a fraction. And there's different ways that I could work this out. I could go straight to the property, or I could write it out. I find that when we're first learning, I really want you guys to visualize what's going on and how math is working. And my go-to is always to write it out, even if it's long and painful. So 13 to the 8th power means I need to have 8 factors of 13. And then in my denominator, I would have 2 factors of 13. And they have now 2 factors on the top and bottom now that I can divide out because they equal to 1. So if I've taken 2 of those factors away, then I'm really subtracting 8 minus 2. And let's just look at this. 8 minus 2 is 6, and it works out. I have 6 factors left. So I have 13 to the 6th power. So even when I'm using those properties, I'm really visualizing all those factors in my head and what's happening, that I'm crossing 2 of them out and how many am I left with. And when I use that kind of language, it's really easy for me to understand how I come up with 13 to the 6th power. For example 3, we're going to simplify 5 to the 3rd times 5 to the 4th. So 5 to the 3rd means I'm multiplying 3 factors of 5 times 5 to the 4th means I'm multiplying 4 factors of 5. So I wrote them all out. I have 3 factors and I have 4 more factors. So how many factors do I have all together? That means I'm really adding those. And the 3 factors plus the 4 factors would be 7. So I have 5 to the 7th power. Example 4, a word problem. A gidget is 3 to the 10th power in size, and a widget is 3 to the 30th power in size. So these are really big widgets and gidgets, apparently. How many gidgets could fit inside a widget? So if we're asking how many could fit inside, we really want to know how much bigger is one thing than the other thing. So we're really dividing. So we're going to take widget, which is the bigger one, and we're going to be dividing by gidget, because we want to know how many times bigger is that gidget, how many widgets could fit inside it. So that means we're doing 3 to the 30th divided by 3 to the 10th. And then I'm going to write it as a fraction. 3 to the 30th divided by 3 to the 10th. So this is where I really probably don't want to write out 33s. This is where all that practice with properties and visualizing is going to pay off now. So here I have 30 factors written out. Here I have 10. I can cross out 10 of those factors and take those 10 away. I would be left with 3 to the 20th power. So 3 to the 20th could fit inside. Example 5, simplify each of the following expressions. Circle the two that are equivalent. So for a longer problem like this, my go-to is probably also going to be those properties where I'm adding or subtracting or doing whatever I need to do. But it's always good to still be thinking through that language and visualizing what's happening. So with this first one, 2 to the 8th times 2, I'm thinking right now that I have 8 2's all multiplied out, and then I'm multiplying it by one more 2. So I know I will have 2 to the 9th power. And that works when I add their exponents. 2 to the 8th, my exponent's 8 plus the 1 over here. 8 plus 1 would be 9. On the next one, I have 2 to the 3rd. That means I have 3 factors of 2. I have 5 more factors of 2. Altogether, I have 8 factors of 2. 2 to the 0th power would just be 1. That was our power of 0 rule that we came up with. On the next one, I have 16 2's in my numerator and 2 factors of 2 in the denominator. That means I would take away those 2 factors of 2. I'd be left with 2 to the 14th. And on the last one, 2 to the 11th means I'd have 11 factors of 2 written out, 3 in the denominator. I would take away those 3. I would cross them out on the top and bottom, and I'd be left with 2 to the 8th. So now we want to circle the 2 that are equivalent. So that would be this one right here, and then the one on the end. They both were equal to 2 to the 8th power. If you have any questions, please contact me or your teacher with questions. I think you will be ready if you understand these examples. Make sure you've taken notes. You might want to go back and refer to those later. But you're ready to go ahead and take the quiz that goes along with this lesson now.